My name is Samir Khan, and I'm the product manager for MapleFlow. MapleFlow is a new tool for engineering math. It was released in March of 2021, so it's nearly a year old. We've built a number of design principles into MapleFlow that we think will appeal to civil engineers doing design calculations. We'll start off with a few slides just to set the scene. I'll talk about some of MapleFlow's design principles, the value it offers to civil engineers, what kind of things you can do with it. Then I'll give you a brief demo of MapleFlow. And as Rochelle said, at the end of the webinar, we'll have time for some questions and answers. So, what kind of calculations do civil and structural engineers do? There's a very broad answer to that because civil engineers are involved in a very broad spectrum of activity. There are lots of civil engineers out there doing many different things. They might be doing structural steel design, reinforced concrete design, timber engineering, geotechnical engineering, water and hydrology, transportation design, and so on. They might need to ensure code compliance for their calculations with readable, auditable calculation reports. They would probably need to deliver those reports to regulatory bodies or clients. The equations in those reports are probably already formalized in design guides, and often civil engineers just need an easy to use environment for implementing those calculations, but with documentation features as well. Civil engineers doing seismic analysis, for example, those in geotechnical engineering, are probably involved in more mathematically demanding work, and they need access to a far stable tool with everything from data analysis functions to numeric and symbolic solvers. MapleFlow covers both ends of that spectrum and in between as well. So, what is MapleFlow like to use? Well, I think that question can be answered by examining how most civil engineers actually do calculations. When civil engineers start to design calculations, they often don't have all of the steps planned out in computational detail. They don't have a grand plan. They try things out, they correct, they go back, they progress a little. They make baby steps, and they might make mistakes as well on the way. They gradually mold their analysis into a technical document. The design principles that we've engineered into MapleFlow encourages that workflow and perhaps even rewards it. It's a tool that allows you to do sophisticated analysis, but with simple game mechanics. Now, what do I mean by simple game mechanics? Well, in MapleFlow, you can place math, text, images, and plots anywhere on a canvas. Your math evaluates left to right, top to bottom, so it's just like reading a page from a book. Your work, the calculations, updates automatically when you change your design parameter or you modify an equation. MapleFlow understands units as well, so it'll rationalize units for you. It'll convert dimensionally similar units for you. And there's a broad math library based upon the Maple programming language as well. You'll see many of these features in action when I demo MapleFlow in a few minutes. Many of you may be familiar with programming languages like VBA or Python. You might be familiar with spreadsheet tools as well, like Excel. MapleFlow doesn't feel like those tools. It doesn't feel like a programming language or a spreadsheet. It doesn't feel that rigid. MapleFlow feels like you're doing calculations on a piece of paper or a whiteboard, but backed by a computational math engine. Now, the vast majority of engineers don't do calculations all the time. Averaged over a year, it might be 10 or 20% of the time, maybe more, maybe less. And they need to be confident that any tool they use they can dip into and out of without going through a large learning and relearning curve. Now, you don't need a grand plan when you first start using MapleFlow. You just jot down a few equations, define a few parameters, move everything into position, and then you add more detail as you progress through your analysis. And MapleFlow has several features that supports that workflow. The left to right, top to bottom evaluation model, the instantaneous calculation updates, and the ease with which you can move things about. In fact, there's something very satisfying about using MapleFlow. If you're the right type of person, if you have the right mindset, if you enjoy doing math and calculations, MapleFlow is an enjoyable product to use. So what I'd like to do now is go into MapleFlow and show you what it is like to use. So this is MapleFlow. We're not going to go into the product very deeply. I'm just going to explore the broad design principles. This is what you see when you first start up MapleFlow. There are 3 buttons. One to create a new canvas. A canvas is what we call a MapleFlow worksheet. There's a link to a built-in series of tutorials, and there's an application gallery. This is interesting. We'll go into this. So if I click on this, within the product, there are applications, demonstrations, and examples across a number of domains in which we feel MapleFlow has value. So there are applications for aerospace engineering, chemical engineering, chemistry, electrical engineering, hydraulics, and so on. But we're going to go down to the civil and structural engineering section and click on this heading. And this just takes us to more applications for civil engineering. There are applications for structural steel, reinforced concrete, timber, geotechnical engineering, hydrology, transportation, and building thermal design. I'm just going to load up one of these applications at random. Let's say this application, crack width in a doubly reinforced concrete beam, and we'll just look at some of the design principles. So what have we got here? This is a MapleFlow canvas. This is an application that we've already created. At the top, it's a title, a description, and a diagram of the problem. The diagram is something that we simply imported in from an image file that was already on our computer. If I scroll down, I see some parameters. So things like the yield stress, the weight of concrete, the cylinder strength of concrete. And all of these parameters have units associated with them. So the yield stress is in megapascals, and dimensions are in millimeters. If I wanted to, I could have specified dimensions in any other unit as well, like such as feet or inches. If I scroll down to the very bottom, I see equations in natural mathematics notation, so overline division, superscripts powers, proper Greek letters, proper subscripts. Let's see what happens when I change a parameter. Keep an eye on this result at the very bottom. If I change this value and I press enter, well, looks like this thing updated automatically. Let's change it back. There we go. So this result is in millimeters. If I wanted to rescale the result to another dimensionally consistent unit, all I have to do is click inside this math container, expand the context panel, and let's rescale this to, let's say, inches. And let's add in some numeric formatting as well. There we go. let's go back to the start screen, and I'm going to show you a few principles from scratch. So this is a blank MapleFlow canvas. I can click at any point to move the grid cursor. I can move it with my mouse, or I can use the arrow keys on my keyboard, and I can do math anywhere. So I'm just typing in a few equations on my keyboard. I'm using keyboard shortcuts to enter mathematical expressions, but if I wanted to, I could also use the expressions palette here on the left-hand side to enter in a template and fill in the placeholders. I can also insert text at any point. And apply different styles to text. That's simple enough. And I can play about with the font styles, format styles as well. Now, all of these are in containers that I can move about on screen. So I can take this container, move it about on screen with my mouse or my keyboard. If I want everything lined up nicely, I can enable the view of the grid. And I can just line these up so they're flush on the left-hand side if I wanted to. You can also define parameters in MapleFlow and use those in your analysis. And if I change these values of X and Y, you can see the results update automatically. Now, if I take this definition of Y and move it to this point, well, this equation, this math container, doesn't know what the value of Y is, so it's left as an unassigned value in its result. Move it back up, drop it there, and you can see it knows what the value of Y is as well. You can also define units in MapleFlow. So let's define a couple of lengths. You can use keyboard shortcuts to insert units, or you can use the units palette as well. And let's add these two together. There we go. So I may have mentioned earlier that MapleFlow is based upon the Maple programming language. So all of the solvers, the routines, the programming language that you have in Maple, you can use in MapleFlow as well. So if I wanted to, I could use this function to solve an equation or a group of equations numerically. Now, there are lots of neat mathematical utilities in MapleFlow. So there are tools for extracting fluid properties, probability statistics, importing and exporting spreadsheet data, matrix computation, and much more. There's a lot of mathematical depth there, but I'm not going to touch on that any more than this. So what I will do is actually open up a MapleFlow canvas that I'm in the middle of developing. So I've just used those principles that I've shown you already to create this MapleFlow canvas. It's the design of a vehicle security barrier. And we're just going to make a few modifications to it just to prepare it for print and export to a PDF. Let's start by just importing an image. So what I'm going to do is put my grid cursor there, press enter a few times, and if I go to the insert menu and select image, I'm going to insert this image. Oh, not that one. Grab the wrong image there. This is the image I wanted. There. So I'm just going to reduce this in size, just so it fits. And there we go. So if I scroll down this worksheet, you can see I've made a few parameter definitions. I have some equations that I've grabbed from a design guide, specifically the International Building Code. And I'm using that function I showed you earlier, the solve function, to solve a group of equations numerically. And I'm extracting one of the results. Specifically, it's the depth of the footing below grade of this vehicle security barrier. Let's say that I want to place a design check. I want to know if the column flexural and axial capacity is satisfactory or not capacity. Well, I've just created some room there, and I'm just going to write down a couple of equations. So as you can see, I've used Greek letters. So this result is in units of joules, but what I actually want to do is rescale this to a dimensionally consistent unit. I press enter. MapleFlow does the conversion for me, and I'm just going to place a design check here. So I want to return satisfactory if a condition is met. Or not satisfactory otherwise. Let's evaluate this and let's see what it gives us. Well, apparently my design is satisfactory. Now, if I go to the View menu and select Print Extents, I see these dashed guidelines on my canvas. These delineate the boundaries of my chosen page size. If I go to the File Page Setup menu, you can see that I'm using letter size page format in a portrait orientation with these margins. So this delineates the right-hand boundary, and this is the bottom edge of my A4 page. It looks, I may very well have equations which cross the boundary. So what I can do is move them into position like so. Make sure everything fits neatly onto one page. If it doesn't, I can play about with line breaking on the equations, font sizes, and so on. Quite often, people have calculation header blocks in their design calculations. So I've already got a template for a calculation header block on my computer. So if I go to the insert menu, let's select another image, and I think it's that one I wanted. There. So this is just an image with some sign-off boxes. If I wanted to enter text into those sign-off boxes, I could click on this image, click on the text tool on the context bar, and add in some text. Let's just write down my name there, and let's add in a date. All right, so let me just make sure that there are no badly formatted pages. So what will this look like when I export this to a PDF? Well, let's see. File, export as PDF. Let's save that and let's load up the PDF. And there we go. So this is the PDF. It's a faithful reproduction of my Mapleflow canvas. And this is the type of document that I could archive, I could give to a client, a colleague, or a regulatory body. Now, there are a number of neat features that I haven't shown you in Mapleflow for formatting documents. For example, you can hide commands. So for example, if I see something like this and I have the bit in the middle, which is something I want to hide, if I right click on that and select hide commands, I just see that. That command is still there, but I can't see it. If I want to insert collapsible and expandable sections into my Mapleflow canvas, I can do that as well. I can grab a whole bunch of math containers just by clicking and dragging, then go to the insert menu and select section. And there we have it. So I have two horizontal lines, one here, which delineate the bounds of my section. So I can expand and contract that section. And if I wanted to, I could also format the appearance of the section line. Let's change the color, make it a bit thicker. There we go. Section is still there, but the section is formatted a little differently than the default. So there is much more I could show you, many more applications. But let's put that to one side for the moment. What I'd like to do now is actually spend a minute talking about how we differentiate between Maple and Mapleflow. As many of you may already be aware, Maple is our tool for mathematical modeling and mathematically oriented work. And Mapleflow is a tool that we released last year that's specifically for design engineers, so people doing design calculations. 1 + 1 is equal to 2 in both packages. Both packages have the same underlying mathematical engine, but the design is different, which makes them appropriate for different groups of people. Maple has a word processor-like environment that's optimized for mathematically intensive work. So work in which you're actually deriving equations, doing algorithm development. Typically, it's mathematically oriented work to support advanced engineering. Whereas Mapleflow is designed for the broad bottom base of the pyramid. There are many, many engineers who wouldn't self-identify as mathematicians, but they do calculations a lot of the time. Mapleflow is really designed as a daily driver for the type of calculations that you do regularly. It has a paper-like environment. You can write calculations and text anywhere. You can insert images anywhere, move them into position. And the very design encourages you to experiment. You don't have to have a grand plan when you start off your Mapleflow-based analysis. you can just start by jotting down a few equations, defining a few parameters, you move everything to position, and then based upon what you see, you can either progress or correct any mistakes you've made. If you would like to try MapleFlow, then you can download a free trial at this address. So just go to our website, go onto the MapleFlow section, and there'll be a link to start a free trial.